Hey, good morning, all you MRWC fans. This is Mr. Aynesworth, and we are in MRWC. We're in section 7, and we're going to start our first activity, 7A1, with some discussion points. And what we want to do is talk about what's called the window frame convention. Like, how do you interpret these graphs in respect to their domain, their range, their minimum and maximum values of both the domain and the range. So what we need to do is first start off with a couple basic definitions of domain and range, and then we'll start talking about these graphs, and I'll talk about how to interpret the graph in respect to its window frame. Okay, so the window frame is this dotted line that you see around each one of these graphs. And so what does it mean when a graph touches the window frame, and what does it mean when it doesn't touch the window frame? Okay, so first of all, let's define some basic concepts of domain and range. And there's different definitions of domain and range, but I'm just going to give you a short, concise definition for both. Okay, so the domain is the set of all possible x values. Okay, and I'm using the variable x as our input variable, although it doesn't have to be. But it's basically, if we're using x and y as our function values or function variables, then the domain is a set of all possible x values, okay, if x is being used for the function, all right, and it's also defined as the input variable. Okay, it's the input of a function. So if we're not using x as our input variable, then it's whatever the input variable is. Okay, but it's a set of all possible x values or the input in a function. Now the range is different. Okay, it's a set of all possible y values if we're dealing with, like, say, f of x equals, some linear or quadratic function or something. So the set of all possible y values in this case, and we regard that as the output of the function. Okay, so the output is the y value, and the input is the x value. So whatever you put into the function is the domain, and whatever you get out of the function, typically a y value, is called the range. Okay, so keep that in mind. And these have to be obviously understood. Major concept in this section here. So what is the window frame convention all about? And what we want to do is explain in words, okay? A couple things here. We want to explain in words the information that the graphs provide about the domain, okay, and the ranges of the functions. So these curves in here, these are parabolas probably. We don't really know, but I'm assuming they are. All right, have a specific domain and the range depending on where they start and end, and their high, minimum or their maximum points. Okay, so domains sometimes have a minimum, maximum. So do the ranges. If they do, we need to define it. And if they don't have a min-max, they might be the set of all reals. Okay, so when you graph functions, is that we're always talking about real numbers. Okay, so let me expand the graph here so we can see them a little bit better. Okay, so here we go. Window frame. So this window frame is this dotted line, first of all. Okay, so the window frame, we'll just do it. I'm not going to do this every single time, but it's this dotted line. And the function may hit the window frame and it may not, okay? And it means something different when it hits it and when it doesn't. So for example, okay, let's talk about the first one here. We'll call this function f of x, okay? It's a function, and it could be a parabola. It could be a portion of a cubic too, we really don't know. But we'll call this function f of x. And this function hits the window frame here, and it hits it here. Okay, and nowhere else does it hit the window frame. And when it hits the window frame, that means that it continues forever in that general direction here. So at this point right here, this is the end of the window frame. And what that means is that it continues forever in that fashion. Okay, so this means when it hits the end of the window frame, it continues forever. Okay, there's no stop. Okay, so it continues forever in that direction, basically. I'm going to say in that fashion, because we really don't know what happens after that. We just know it continues. Okay, so it continues forever in that fashion. I'm going to say in that fashion because we really don't know exactly what it's doing. All right, because I don't know if it's a parabola or a cubic. I really don't know. Or some kind of polynomial function. It could go up and down, up and down, up and down. Who knows? All right, but it hits the end of window frame. And what that means is that it continues. Keyword continues. So, typically we put arrows there, but we're not doing that anymore. We're going to be seeing these things called window frames. Now, same thing here. At this point here, and we'll call this point A, it continues. At point B, it continues as well. All right, so I'm just going to write the word continuous here. All right, so because of that, I know the domain. And what we want to do is describe in words what the domain is. So we're going to use D for domain and R for range just to make it simple, because I don't have a whole lot of room to write here. So D for domain. So we have to describe it in words and then write it in symbols. Okay, so because all of these points on the graph, let me switch to red here so you can see this here. All of these points on the graph, they're all x values and y values, okay? So this x value, I don't know what it is, but if you go down to the x-axis, it's negative something. This x value is, I don't know what it is, but it's negative something. All these points on the graph have x values, okay? And you get the x values by going up to the x-axis and reading the graph. Although I don't have any scale on the graph yet, I do. That's how you do it. Okay, if you want to figure out the x value of any point, you simply go down to the x-axis. Okay. Now, because this graph goes forever to the left and it goes forever to the right, okay, the domain is infinite. Okay, meaning that it's a set of all reals. Okay, there's no end to the domain to the left. Okay, this graph keeps on going to the left towards negative infinity, and it keeps going to the right towards positive infinity. Okay, so you get used to these symbols right here. This the symbol here is the infinity symbol. Hopefully you guys saw that before in your previous course in Algebra 2. Okay, so because it continues to the left and also continues to the right, the domain has no minimum, no maximum. So it's the set of all real numbers. Okay, you can use the capital R with two vertical lines. That's the symbol for the set of all reals. And in interval notation, you write it like this: negative infinity to positive infinity. That's called interval notation. Now, in the directions, it just said it's explained in words, but so I'm going a little bit over and above because that's the way I roll. Okay, talking about interval notation as well. So you explain it in words first, and then you write it in the correct notation. Now, the range is a set of all possible y values. So I'm going to switch colors here. I'm going to go to blue. Okay. Now, this point on the graph, I don't know what the y value is, but if you're going to read the y value, you simply go to the y-axis and read it. It's some positive value. This point on the graph has some y value, and it's read by going to the y-axis. It's positive. This y value is 0 because you're on the x-axis. Okay, if you just read it, it's 0 right there. And then it has this low point, and this low point is at its vertex. Okay, and we call that a minimum. So it's y minimum. And so that point right there, I don't know what it is, but let's call it A, okay? So that has a minimum value. It has a low point. A minimum is a low point. The maximum is the opposite of that. It's a high point, okay? And you heard these words in Algebra 1 when you talked about parabolas. They have vertices, and they are either minimums or maximums. And then you also heard in Algebra 2 when you talked about quadratics and cubics and polynomials that go up and down. They have minimums and maximums. In fact, you probably heard of things called relative minimums and relative maximums. We're going to talk about that later as well. All right. So this function here has a low point, a minimum y value at A, and then it keeps on going up forever. It goes up forever, and so it has no max. Okay, this function has no max, but it has a minimum. Okay, so when you describe the range, you can say it's all reals. Okay, these are always real numbers. Okay, all reals greater than or equal to A, because A is the minimum or the lowest point. Okay, and you could also describe it like this: y is greater than or equal to A. And I use the y variable because we're talking about the range. Remember, x is typically the variable for the domain, all the input values for x. as I said up at the very top of the screen, and then the range is a set of all possible y values. Okay. Now, if you want to write it in interval notation, you would write it as, close brackets. Okay, so you go close bracket because we're going to include a, okay, comma, positive infinity, and then open. We'll talk about the interval notation more later. I'm just adding that into the conversation just to give you your first experience on it. And then in later activities here, or in later discussions, actually the next discussion, we'll talk about the interval notation a little bit more specifically to get a little bit more practice. Because you started your discussion on interval notation in Algebra 2 last year, for those people that are coming out of Algebra 2. So you should have seen it, but in this section, or in this class here in MRWC, we're going to get really get in depth, and we're going to talk about it and get good at it. All right, because it's a lot more concise way to write the domain and the range using interval notation. All right, in graph 2, or the second graph here, part B, okay, I noticed that at this point right here, it does not hit the window frame. So in respect to the domain, it has a minimum value. So you go down here and let's call this point A. So that's going to be the minimum value of the domain. Okay, it's an x value here because the graph doesn't continue to the left. It starts there. So this is where the graph starts. If you read it from left to right, always read it from left to right. Left to right. Okay, read left to right. Okay, so the graph goes from left to right. So it has a starting point, and then it doesn't. Right here, it hits the window frame, so it continues here. See, that means the abbreviation for it continues. And so it's going to continue in this direction here towards positive infinity. So the domain starts at A, and if you cruise along the function here, the x values get bigger and bigger because when you go to the right, okay, on the x-axis here, you know, obviously they get greater right there. I don't know what it is, but it's a positive value. And then it gets bigger and bigger and bigger and bigger, and it just keeps on going forever. So the domain here on this one is different than the previous one. So the domain here starts at A, and it goes on to positive infinity. So I can say that it's all reals greater than or equal to A. So all reals greater than or equal to A, because that is the smallest x value, or the min x value. Okay, and the way you write that in interval notation is close bracket A to positive infinity. And you always have open on the infinity side because, well, that's infinity. You can never reach infinity, okay? So it's always open on that side, which means it does not include that point, okay? Because there's no end to infinity. It just keeps on getting bigger and bigger in terms of the x values. Now the y values different. So the y values, this y value, I don't know what it is, but it's some positive value right here on the y-axis, and it goes down, 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 down to this vertex right here at a minimum value. And the way you read that is by looking at the y-axis right there, and let's call that b, let's say. So b equals a minimum y value. And so the range is different, okay, on this one. It has a minimum y value, and then if you cruise along the function and go up, 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 and like what Buzz Lightyear says, you go up, up, and to infinity and beyond, okay, it goes to positive infinity on the y-axis. It keeps getting larger and larger and larger. So the range is all reals greater than or equal to b. All reals, all right, greater than or equal to b. Or you can say b comma positive infinity if you want to, in terms of interval notation. Okay, so the y values increase and go up forever, but they have a low point. So we start at b and go up. On the domain, you got look laterally. You look left and right, and you look on the x-axis because the domain is a set of all possible x values. And you start at a and go to the right, and so a to positive infinity. So you need to train your eyes on how to read the graph using what's called a window frame convention, and be able to write it in words descriptively, and you also need to write it in interval notation as well. Now in the third graph, this one's different. It has a starting point here if we're reading left to right, okay, and it goes down and then back up. Okay, again, I'm going to use arrows to indicate the way you read it, okay, from left to right. And so it has a start basically and a stop, and notice that it does not touch the window frame. So because of that, the domain starts here. Well, let's call this point A. I just use the first letter in the alphabet. That's all I do. I'm just making up these variables. And it goes, and the values of x on this graph here, if you just cruise along the function, you're going to the right on the x-axis. So they're getting bigger and bigger and bigger and bigger, okay? And they stop here, wherever that is. Okay, we'll call that B. So the x values start at A and they go to B. So it's all reals from A to B. That's the domain. So the domain D, okay, all reals, all right, greater than or equal to A but less than or equal to B, okay? So basically from A to B, and the way you write that in interval notation, or well, actually inequalities you can write like this: A is less than or equal to X, less than or equal to B, or you can say close brackets A comma B in interval notation. Okay. Again, all of this should have been discussed in your Algebra 2 course. I sure hope so. If your Algebra 2 teachers were doing their job, okay. Not in Algebra 1. We don't do interval notation in Algebra 1, but we do talk about domain and range. And in Algebra 2 and pre-calc, we talk about interval notation. Now the range is different. So the range, it has this. If you start here and cruise along the function, it has this minimum point right here, this y minimum. We'll call this point C. C is called a minimum y value. So we'll just call it minimum y min. Okay, so it has a minimum y value, and then it has a maximum y value here. So you go to the y-axis to find your y values. I mean, that's what you do. Okay, and so it has a y max up here. Okay, and let's call that, let me see, A, B, C, and then we're at D. So let's call the y max equal to D. So the range is all reals from C to D. So all reals, okay, from C to D. And the way you write that is C less than or equal to Y now, because we're talking about Y values, is less than or equal to D. And in closed interval notation, you write it as C comma D. So yeah, this is a very important lesson here, guys, because we're talking about multiple things. We're talking about window frame convention and how to read the graph given a window frame. We're talking about the domain, how to describe it in words, how to write it as an interval. Okay, there's a lot involved, so you can't really just take this lesson lightly because there's a lot involved. Okay, believe it or not. But mathematicians are always concise, and we write everything symbolically, so you have to be able to translate from words to interval notation and back and forth, because using symbols is a very, very concise way to describe a concept about either the domain or the range. Okay, last one. So on the last graph here, okay, I noticed that it hits the window frame here, so it continues, and then it stops here, okay, because it doesn't hit the window frame. So let's talk about the domain first. So the domain, again, read it from left to right. So your eyes are, you notice that we start, or it doesn't stop there. All right, so it's going to go to negative infinity. So the x values, if you go down to the x-axis and go straight down, it's negative something right here, and this point right here on the graph, the x value is negative something. Don't know exactly what it is, but if you continue going to the left on this graph, it keeps on going to the upper left forever and ever. So the x values have no limit to the left, okay, towards negative infinity. But they do stop over here. The last x value, the maximum x value, is right here. So let's call it A, okay? And A in this case is a max x value. Max x value. Or x max, okay? Yeah, let's call it x max. X max, okay? So it's all reals. All these x values here are all less than or equal to A because they are to the left of A, okay? And they have no limit going to the left. So all reals less than or equal to A, whatever A may be. It could be 5, it could be 10, who knows? Okay, now in interval notation, it would be open, okay, negative infinity to A, closed, because you want to include A. It's less than or equal to A. Not less than A, but less than or equal to A. Now the range is a set of all possible y values, and there's no y max, okay? So because it hits the window frame, it keeps on going up, okay? It keeps on going in this direction. So no y max, okay? No y max, but it has a y minimum right here, okay? So this is the y minimum. Let's call it B, okay? Just the next letter in the alphabet. So the range here, the range is equal to all y values, all reals. These are always real numbers, by the way. Okay, we're not on the complex plane. We're on the xy coordinate plane, on a real plane. So all real values, all reals greater than or equal to b. Okay, greater than or equal to b. And you can write that as b to positive infinity. Okay, if you keep going up on the y-axis here, it goes to positive infinity. Okay, going down to negative infinity, going up to positive infinity. Okay, now those were probably quadratics. These are probably parabolas in the first four graphs. Not sure, but they might be. And they sure look like them. All right, but down and below, these are more like cubics. Okay, you've seen these in Algebra 2 as well. So these are typical cubic curves, third degree cubics, probably. Don't know exactly, but actually there's a asymptote here. So probably not, actually. So I'm going to take back what I just said. It depends. I really don't know. Okay, so the only thing I do know is that it starts here. Okay, and if you, again, you're reading left to right. So if you read it from left to right and just follow the arrows here, okay, it goes up and then it has this max, relative max. It's called a relative max, but it's a maximum y value. So let's call it, I don't know, we'll call it something in a minute. And then it goes back down. Again, these are arrows. And then it has a minimum right here, a relative minimum, and then it goes back up again forever. Okay, and then it hits the window frame here, so it continues. All right, so here we go. Let's start talking about the domain first. So again, domain, you have to look on the x-axis. Okay, the x-axis is here, and the y-axis is up top here, vertical. So in terms of the x value, it starts, you got to go up to the x-axis, and it starts right there. And so let's call that x value a. I don't know what a is. It could be -5, -6, -10. It could be -10,000. We don't really know because we don't have a scale in the graph. So let's call that a is an x minimum. X minimum. All right, we don't know what it is, but if you cruise along the graph, okay, and you go from left to right, and the x values keep getting larger because you're going to the right. You know, on the x-axis, if you go to the right, guys, you get bigger. Okay, it's just use your common sense. And then you go up top here, and any point on this graph here, you're going to the right a little bit, but then it stops right here. And this is an asymptote. Okay, it's an imaginary line. Okay, let me just highlight this here. So the asymptote is an imaginary line that the function approaches, and it gets infinitely close, but it never really touches that asymptote. Okay, so, and let's say that asymptote occurs at, you know, some x value, and let's call this x value b. I don't know what this value is. It could be 5. So this could be a vertical line through 5 or 10 or whatever it may be, but I don't really know, so let's call it b. So the x values start at a, and they include a, and they go all the way to b. So the domain here is all reals, okay, from a to b, including the a. Okay, so all reals greater than or equal to a and less than b, because you can't touch b, and less than b. The way you write that is this right here. So a is less than or equal to x, which is less than b. Or if you want to use interval notation, you go closed bracket on a, comma, b, and then you go open. Open means you don't include it, because again, the function goes up and approaches this asymptote, but it never touches it, right? So it can never be, the x values can never be equal to b, and that's why it's either less than b or not including b, one of the two. Now the range is different, okay? Now the range, it has a low point here, so this is y minimum, whatever this is, and let's call it c, and c is a y minimum, because it has a low point right there. It doesn't get any lower than that. It goes up, and it has a relative max, and it comes back down, and then but this minimum here is not lower than the first minimum. So this right here is it's obviously smaller, or lower, smaller than the other y minimum, and then it doesn't have any max. Okay, so right here, no y max, because it goes up forever, okay, to infinity and beyond. Okay, I'm talking about positive infinity. So the range is a set of all reals, okay, greater than or equal to c, whatever that may be. So greater than or equal to c, all right, and that's it, all right, and it goes to positive infinity. And so the way you write that is c comma positive infinity. Okay, next one. Okay, similar graph here, but it's different. Okay, it's different, so be careful. You notice that it hits the window frame here, so it continues. It keeps going forever. All right, here it stops. It stops there. It does not go on forever. So this right here, they look similar, but you got to really look closely here, guys. These are different. So pay attention and look closely here. So the domain. Okay, so because of that, this right here, the domain, it keeps on going to the lower left and does not stop. So it goes to negative infinity to the left, but then it stops right here, whatever that may be. Let's go to the x-axis and give this a name, like, I don't know, A. Okay, so the domain is all reals less than or equal to A, because it keeps on going to the left forever, and the A value is a max. Okay, this is an x max. So all reals, okay, less than or equal to A. Okay, you can also say negative infinity, and then comma A closed. Okay, now the range is different. So the range, y values, again, x values, range, y values. Now the y values, since the function continues forever down here, that tells me that there's no y minimum. So no y minimum, because it keeps on going down and down and down. It has a relative max here, it has a relative min here, and then it has a maximum. So there's no minimum y value, but there is a y max, and whatever that is, it's right here. So let's call that B, all right? And this is equal to a y max. So when you describe the range, you could say all reals less than or equal to B. Okay, or you can use interval notation. You can go negative infinity, comma B inclusively, so go closed. So yeah, I'm using a lot of vocabulary here, as you guys can tell, and again, you can't take this lesson lightly because there's a lot involved. And like I said, this section is very demanding. Section 7, very demanding. And there's a lot of vocabulary, a lot of concepts here, and that's why it's going to be so important for you guys to go through the prep videos, because if you don't, and here you could be struggling in the future here. Unless, of course, you got A's in Algebra 1 and 2, and you fully understood everything, and you had a really good teacher that really taught the concepts, and really you had a really good rigorous teacher. Okay, and hopefully that was the case. Okay, now number 3, these are different. All right, so let's go through number 3. All right, so these are fun. So these are graphs of probably either sine or cosine functions, or portions of sine or cosine functions. We really don't know, but I'm guessing that because it has a very familiar look. And let's just analyze a few things. So first of all, I notice that it hits the window frame here and here. Okay, so the graph continues here. Okay, and it continues here because it hits the window frame. Okay, whereas opposed to right here on the second graph, it stops right here. It stops. And then it continues here. See, so these graphs, even though they go up and down, they look similar, they're different. So be careful. You got to look very, very closely here. So on this one here, I noticed that it has, let me see, on the x-axis here, we got negative infinity to the left, we got positive infinity to the right. Up on the y-axis here, We've got positive infinity going up, and we got negative infinity going down. So let's see what's going on here. So on the x-axis here, if you cruise along the function left to right, again, you always analyze functions left to right. So if you go start here, sorry about that, and I'm drawing arrows now. If you follow the function, and the arrows describe the way you should be looking, okay? If you cruise along the function left to right, no, up, down, okay? If you read the function from left to right, there is no limit to the x values to the left because it hits the window frame and continues to the left. There's no limit to the x values to the right, to positive infinity, because it hits the window frame and it continues forever to the right. That tells me that the domain is a set of all reals, okay? You can just say capital R. Or you can say negative infinity, comma, positive infinity. That's an interval notation. On the range is different. The range has a minimum, okay? There's a y minimum here. Whatever, let's call that A. A is the y minimum. And then it has a high point right here. I don't know what that y value is, but let's call it B, and this is a y max. Okay, high point, y max equals high point, y minimum, low point. Okay, high and low, very, very simple. So the range has to be between these 2 points, between A and B. And be careful, it's inclusively, meaning that it includes A and B. So all reals, all right, from A to B, from A to B. The way you write that is you say A is less than or equal to y value. Again, we're describing the range, so we use a y variable. Less than or equal to B, or you can say closed from A to B. All right, not open but closed, because it could, you got to include A and you got to include B. So closed interval notation means that it includes A and B. Closed means that it includes the point. Open means it does not include the point. Okay, now on B it's different. Okay, the domain starts here at whatever this value is, call it A, and it doesn't stop here because it continues forever to positive infinity. So the domain is different on the second graph. It's from A, so all reals greater than or equal to A. So all reals greater than or equal to A, or you can say A comma positive infinity. On the range, it's different. Okay, the low point is at this point. This is a y minimum. Okay, let's say that is at A right here, and then the max is right up here at B, so this is a y max, and A is a y minimum, so the range is different. So all reals from the minimum to the maximum, from A to B. So from A to B, okay, or you can say A is less than or equal to Y, which is less than or equal to B. That's using inequalities, or you can say closed A comma B. Okay, that means it includes A and B. Now the third graph is different than the previous two. I have a starting point here, and I have an ending point here. So the domain is different than the previous domain. So if we start the x-axis, we start the x values at A and stop them at B, then the domain here is all reals from A to B. Or you can say A is less than or equal to X, less than or equal to B, or you can just simply use interval notation, closed from A to B. Now the range is different, and the range is the same as the previous one here. Okay, it has a low point right here. This is called a y minimum. Y minimum. Let's call this A, and it has a y max. Let's call it at B. So the range is the same as the previous one. So all reals from A to B. and then you can write that A comma B. Okay? All right, yeah, this is technical, isn't it? I mean, it looks like a simple thing here, guys, but it's really not. And that's why I said that this section is challenging, because there's a lot of vocabulary, a lot of conceptual, abstract thinking going on, and there's a lot of symbols going on. And so you have to interpret, go from words to symbols, from symbols to words. You've got to be able to go back and forth. All right, and that's why it's so important that you guys go through these video tutorials to get the basics down, because even though this was taught in Algebra 2, or it should have been taught in Algebra 2, did you really understand it? I don't know. That's up for you to decide. All right, part 2, last discussion point before we get into your activity here on 7A1. All right, we're going to talk about how to interpret the real number line and how to write it in interval notation. So we're going to continue discussing what I just discussed. We're going to use interval notation if possible. So let's highlight that. Use interval notation. If it's not possible, if it's not appropriate, then what list, all right, can be used to describe it, as you're going to find out. Okay, sometimes it's possible using interval notation, but if it's discrete, like in the third one here, we're going to have to write it a little bit differently. Okay, so first of all, you've seen this starting in Algebra 1, believe it or not, when you started using inequalities to describe these graphs. So x can be any number in this interval. Okay, so I'm going to just put an x right here. So x can be, it can't be -2 because this is open. This one's closed right here. Okay, it should be shaded in, it's closed. So it's open at -2 and closed at 4. Now what this means is that closed means it includes 4, so the domain includes. So closed means it includes the point, includes 4. If it's open, that means it excludes or does not include -2. Okay, so open means it does not, keyword not, include the point. Include, in this case, -2. So you have to understand what open and close means. Very, very key concept. Right there. You saw this starting in Algebra 1. I know I teach it in Algebra 1, and it's very, very important concept. So this domain right here, or this interval, this is called an interval, includes all points from -2, but not including -2, all the way to 4 and including 4. So all reals, let's write it out in words. So all reals between -2 and 4, so between, I'm going to use the keyword between -2 and 4, okay, and including, between means that it doesn't include, okay, but I need to include 4 because it's closed. So I'm going to say including 4. Okay, that's how you write it in words. All reals from -2 or between -2 and 4, including 4. The key word right there is between. Now, the word between means that it does include a -2 and 4, and that's why I have to do comma, including 4. So keep that in mind. Now, interval notation, you write it like this. Okay, open at -2 because it does not include it. That's the open symbol. And then you go comma 4, then you go closed. So this symbol means open. This square bracket means closed. Okay, and so that's how this is called interval notation. Interval notation. So we write it in words here. The first one in words. So you write it in words, and then you write it in interval notation. And this right here is a very, very important concept in mathematics. So you have to understand what the domain is of a function. And we usually write that in both words and symbols, and you have to be able to go back and forth. So even though this seems like a very simple exercise, all right, there's a lot to it. All right, and it's actually very, very important to set up the rest of the section. Okay, now the second graph is totally different. So notice that it does not have an end here. And notice that there's no arrow either. So because of that, it hits the end of the window right here. And so this continues forever. So right here, I notice that it continues to positive infinity, okay, to positive infinity. Let's put that down. So the interval here, x can be any value. I'm just going to put x here. It could be any number beyond 4, all right, to the right of 4, which means I don't include this. This is open, okay, so do not include 4. Do not, all right, include the 4. So the way you write that is you say all reals greater than 4. So all reals greater than 4. Now notice that I didn't say greater than or equal to, because it's open. So the way you write that in inequalities, you say x greater than 4, and you've seen that in Algebra 1, okay, and then also Algebra 2. And then the way you write that in interval notation is very simple. You just go open at 4, comma, positive infinity. Okay, so 4 to infinity. Okay, and you always go open on infinity because infinity is not a number; it's a concept. There's no end to infinity. So infinity is always open there. Now on the third one here in graph C, there's no it's discrete. It's not a continuous function. So it's not continuous, but it's equally spaced. Okay, so let's notice something here that is it's equally spaced. Okay, so what are these numbers here in the middle? So let's just denote it here. So negative 2, negative 1, 0, 1, 2, 3, 4. Okay, so this graph here is totally different than the previous two because these are just numbers from negative 2 to 4, but don't include all the numbers between them. So this set right here is from it includes negative 2, negative 1, 0, 1, 2, 3, and 4, but not all the numbers between these numbers here. So these are all the integers from negative 2 to 4. Okay, only integers, not rational numbers. So only integers from negative 2 to 4. Okay, not the rationals in between them. So in this case, we have to list. That's what it means right here. If interval notation is not appropriate, what list can be used to describe that? Okay, and the list is right here. So you have to list them. All right, because we're talking about 1, 2, 3, 4, 5, 6, 7 discrete points. So if it's not a continuous function like the previous two, okay, it's a continuous function here on the first two, then you have to list it. All right. Now the next few are a little bit different here. So in this graph here, x can be any number to the left of negative 2. Okay, so this is negative infinity here, and this is positive infinity here. So here, all reals less than 2. So this portion here, you can say all reals less than negative 2. Okay, in interval notation, you go negative infinity to negative 2. Okay, or x can be over here, and that's closed, so this one's open, this one's closed. So you can say all reals greater than or equal to 4. So x can be all reals less than 2 on the first portion of the graph, or, keyword or, make sure you put that. Okay, all reals greater than or equal to 4, and the way you write that is you go closed at 4, comma, positive infinity. There you go. You can also use the union symbol here too. So if you want to write this using a union symbol, like you talked about in Algebra 2, you can do that as well. You can say, you can go open at negative infinity, comma, negative 2, union, all right, closed 4, comma, positive infinity. Okay, that's how you write the statement using the union symbol right here. Okay, next one, discrete function here, so we're going to just have to list them out. Okay, so here requires a list. So 2 here, and this is 1, let's say, and this is 0, obviously -1, -2, okay, -2, and so on. It keeps on going to negative infinity. So this one here we have to write a list out. So starting at 2, 1, 0, -1, -2, comma, dot, 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 dot. So the dot, dot, dot right there means that you have an infinite list. This is an infinite list. Okay, so it doesn't contain just like 7 numbers like the previous list. So that was a finite list. Finite meaning that you have a specific number of elements in the list, whereas graph E right here, it's an infinite list, and so it goes towards negative infinity to the left because there's no end. It just keeps on going. Okay. Now graph F is different. So F, it's all reals, okay, or all numbers that include -4, but do not include 2. So we're closed at -4, but we're open at 2. So it's all reals from between -4 and 2, including the -4, but not 2. So you say all reals, all right, between -4 and 2. Okay, and then you have to be specific here. We include -4, but not 2. So including -4 because it's closed, and not, all right, 2 because it's open. The way you write that in interval notation, you simply go closed at -4, comma 2. So you can see how how nice it is knowing, having symbols to describe things. So because instead of writing all these words out, you just simply write this interval notation. Remember, the closed bracket, the square brackets mean closed, and the round brackets, well, that means open. So this interval notation right here is preferred because it's very quick to write, it's quick to interpret once you get it, and it's much more concise. And that's what, mathematicians do. We write things very concisely using symbolic notation called interval notation. Okay, and then the last one here, this is a cool one here. You go from, this graph doesn't end to the left because it hits the end of the window frame, and it doesn't end on the right either because it hits the end of the window frame. All right, but it's open here at 2. So x can be any number over here to the left of -2 and any number here to the right of -2, which means it's all reals except -2. So that's how you write it, all reals except, okay, -2. Okay, so the way you write that is you have to use 2 intervals. Okay, you have to say the interval on the left here, so from -infinity to -2, okay, union -infinity to, -2 to positive infinity. You have to break it up into 2 intervals if you're going to write it in interval notation. Or you can simply say x is not equal to -2 using inequalities. Okay, so this is called interval notation. That's what I've been talking about the entire time today. Interval notation. Okay, and this is called an inequality. All right, so this is what we want to get good at. You want to be able to write things using interval notation. All right, and I know that was a pretty intense video right there. That was kind of a long video, and again, this lesson is not easy because it is intense. I mean, it's got a lot of vocabulary and a lot of new symbols to use, and so take time and go through this and take it seriously because this is like the prerequisite basic skills that you need to be successful throughout the section here. All right, so do your best, go at your own pace. If you have to watch any portion of this again, do it because, again, this is the prereqs. This is the stuff that you need to understand before you get into your next activity on 7A1 here in MRWC. All right, I'm Mr. Aynesworth. I will see you in my next lesson. All right, take care, do your best, and make yourself proud, and I'll see you then.